So in this lesson, you're going to learn how to simplify complex fractions. And what are complex fractions? Complex fractions are fractions divided by fractions. So as you can see, this is an example of a complex fraction over here. You have a fraction bar in between another fraction. So these are examples of what they call complex fractions. Also, it's important to note that complex fractions are simplified when it is in the form P over Q, where P and Q are polynomials that have no common factors. So you have simplified and you are done when your numerator and denominator do not have common factors. So let's look at the first method for simplifying complex fractions. And I labeled it 1A. So if this is a fraction divided by a fraction here, we could rewrite this as 4 divided by x, and this little symbol here, which represents division, 2 over xy. So these are equivalent to each other, right? So you're more familiar with this division symbol right here and what to do from this point. Now, we can do this with simpler complex fractions. And there's a method 2 as well, but we're going to get to that in a second. It's better to use method 2 with more complicated complex fractions. All right, so for this one, of course, all we have to do is keep, change, flip, right? Keep, change, flip. So we'll write 4 over x, we'll keep it, we'll change the division symbol to a multiplication symbol, and we'll write the reciprocal of 2 over xy, which is xy over 2. Then we can simplify. 2 goes into 4 2 times, right? 2 goes into itself 1 time. You can also cancel out the common x's, leaving us with a 2y over 1, but always go that step further and divide that numerator by that denominator. So we're going to have 2y as our answer. All right, let's go on to the second method, which is using the LCD. So we're going to work on the same problem, but we're going to use the LCD instead. So we need to look at our denominators here. We have an x and an xy, and determine what is the LCD first. So if we wanted both denominators to be the same, what would be in both denominators? So if you said xy, then you are correct. Now what we're going to do with this LCD is a little unorthodox, okay? But it will work. So what we're going to do is multiply what we consider as the numerator of this complex fraction, and we're going to multiply xy by the denominator of this complex fraction. And what we're going to do is simplify, for example, the x, this first part, we're going to simplify all of this first. And how do you do that? Well, notice that this xy times 4 over x, this xy is really considered to be divided by 1, right? So if so, xy is in the numerator, and because of that, you can get rid of the x's here because that's what's in common. So what's remaining in the numerator, you have that 4, you have that y left, so 4y is remaining there. So what are we canceling from the denominator? All right, again, this is like over 1, so the x in the numerator cancels with the x in the denominator. This y in the numerator cancels with this y in the denominator, and you're left with 2. So can you do anything else? Yes, because 2 divides into 4 2 times. And what we're left is 2y over 1 again, which is 2y. So notice that we get the same answer for method A and method 1 and method 2. Okay. So what we need to concentrate on is which method we want to use for each situation. So I'm going to use method 2 for most of the situations. I only use method 1 when we have something as simple as this situation here, but as you are going to see, our complex fractions become more complex. So let's go to level 2. Notice we have 1/2 plus 3/4 over 5/6 minus 3/8. Again, we're going to use method 2, and the first thing you do is identify what is the LCD of all denominators, top and bottom. And as you can see, 2, 4, 6, and 8 all can divide into 24. Now, what are we doing with this LCD? Again, I know it's unorthodox, but we're going to multiply the entire numerator by that LCD and the entire denominator by that LCD. So what does it mean when you have more than one term and you're multiplying something like 24 times it? Well, you have to distribute, correct? So I'm going to rewrite this as 24 times 1/2 because we're multiplying 24 times everything up here. So that means I have to multiply 24 times 3/4, 24 times 5 over 6 minus 24 times 3/8. Now what we're going to do is simplify each fraction individually. So to do that, for example, again, this 24 is like over 1. So that 24 is in the numerator. 2 goes into 24 12 times. And 12 times this 1 here is 12. So I'm just going to rewrite over here 12 from that. Plus, let's go over here. 4 goes into 24 6 times. But 6 times this 3 here is 18. Let's go to the denominator. 6 goes into 24 4 times, but 4 times this 5 is 20 minus 8 goes into this 24 3 times, and 3 times 3 is 9. All we have to do now is simplify this. 12 plus 18 is 30 divided by 11. So that's our final answer. So the point of multiplying the numerator and denominators by the LCD is to get rid of all of those fractions. So notice we didn't have to deal with all of those fractions here. We just simply were able to get a solid number, and then we simplified that in the end. So let's move on to the next number. Again, we're going to use method 2. The LCD here is what? So we have this denominator and we have this denominator. And if we wanted both denominators to be the same, what must it have to be? It would have to be x squared, right? So what we're going to do with the x squared is we're going to multiply top by x squared and the denominator as well. So again, here we have to distribute because we have more than one term. So what is x squared? I'll write it out here. And I know this might be tedious, but writing it out is going to help you stay organized and keep you on track. So x squared in the denominator is also being multiplied by 1 plus x squared times 2 over x. So don't skip this step if you're not an expert at this just yet. Just write it out. So we have x squared times 1, which is x squared minus, and then notice that this x squared here and this x squared cancels out. So because of that, let me change this. So this x squared and this x squared cancels out. And you're left with here a 4. And the bottom we have x squared times 1 here, which is just x squared, right? But x divided into x squared will give us x. So we have a 2x down here. Now we have a factorable situation here. So x plus 2 times x minus 2 is x squared minus 4. And in the denominator, we can take out an x, which shows you that that's very important that we get that done, because notice that the x plus 2's cancel, and our final answer is x minus 2 over x. All right, next, what is the LCD of number 4? What is the LCD? So the trick is understanding how to determine the LCD. If you get that down, these problems are going to be pretty simple to you. So if you said that the LCD is a squared b squared, then you know what you're doing. All right, so a squared b squared, we're going to multiply a squared b squared times everything up here. So let's write it all out. Now that we've written it all out, let's simplify each fraction separately. So starting with this a here and this a squared. So 1a is being removed from top and bottom. So what we have here is a 6 left over, an a and a b squared, minus, then this b squared here gets knocked out. That's 5a squared. And denominator, the a squares also cancel out. So you have 12b squared minus, then one of the b's cancels out. So you have 2a squared b. Now, can you factor any of this? It looks like you can factor this. So let's attempt to do that. I kind of already know that nothing is going to simplify here, but let me show you that it is factorable because the numerator at least has an a in common. So if you take that a out, you get the other factor of 6b squared minus 5a divided by, and the denominator, you have a 2 in common, you have a b in common. So that is 6b minus a squared. So notice here that nothing is the same top and bottom, so nothing cancels out. So both of these answers are equivalent and both are correct. Let's move on to number 5. What is the LCD? So try to call out the LCD before I reveal the LCD so that you'll know whether or not you understand how to find the LCD. So what is the LCD here? The LCD is xy squared. So that's what we're going to multiply numerator and denominator by, xy squared. And let's write it all out. We have an x. We have an xy squared times 3 over x plus xy squared times 2 over y divided by xy squared times 5 over x minus xy squared times 6 over y squared. Now what we can do now is cancel out common factors. So notice that those x's go away. We're only left with 3y squared there, plus 1y goes away here, so that's 2xy. And the denominator, the x's go away there, so 5y squared minus, and the y squares go away, so that's 6x. Now you could potentially take out a y here, then that leaves you with 3y plus 2x. But notice that the denominator is not factorable at all, so there's nothing else to simplify. Either answer is correct. Let's move on to number 6. What is the LCD is the question. If you said 4x squared, then you are right. 4x squared. So again, we're going to multiply 4x squared times every term. So now that we have written out everything, let's cancel common factors. So notice that 2 divides into 4 2 times. So that's going to leave us with a 2x squared plus. Then one of these x's goes away, but then we're going to have to multiply this 4 times this 2. We got an 8x left over here. Then the 4's cancel. We have x squared minus the x squares cancel. But don't forget to multiply that 4 times 4, which is 16. This is an interesting problem because both numerator and denominator are factorable. So we're going to factor out the GCF of 2x from the numerator, leaving us with a factor of x plus 4. In the denominator, we have a difference of squares. So this will allow us to cancel common factors, and we are left with 2x over x minus 4. Now let's move on to level 3, which seems a little bit more complicated, but it's okay. Let's look at our denominators here. X squared, x squared. What is the LCD of these denominators? So if you said x squared, then you are correct. We're going to multiply x squared times everything. So pause the video and write out everything out. So x squared times everything you see. So first thing we're going to do is notice that nothing cancels here. They're both on the same level, obviously. So we're just multiplying x squared times 2, which is 2x squared. But next, x is canceled here. We have a 5x and minus the x squares cancel there. So you're left with a 12. The denominator, we have a 4x squared minus the x is canceled here. So you have a 4x minus the x squares cancel. You're left with that 3. Now these are trinomials, as you can see, so you actually must determine whether you can factor that. So, for example, 2x squared plus 5x minus 12. AC method says multiply 2 times negative 12, you get negative 24. Factors of negative 24 or positive 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. So are there factors that add up to 5? And let's see, negative 3 and 8 could work, right? So 2x squared, so this is my little factoring. So I'm factoring off to the side here. So 2x squared minus 3x plus 8x minus 12. So we can take out an x there, that's 2x minus 3. We can take out a 4, that's 2x minus 3. So the factors are 2x minus 3 times x plus 4. So that means that we're gonna rewrite this problem, the numerator at least, as 2x minus 3 times x plus 4. And so I'm going to guess, once you're really good at factoring, you can kind of like guess at the other factors. So I'm going to guess that it's maybe these are the factors: 4x squared plus 2x minus 6x minus 3. Okay, so that works. Now, but always multiply to make sure, right? You need to FOIL it out. I'm going to cancel those factors. And we have x plus 4 over 2x plus 1 as the final answer. The last problem is a little different because notice that the denominator is a minus 2. And let me just say this. If your denominators are factorable, factor the denominators first. Now, a minus 2 is not factorable. Obviously, it's already in its simplest form of a minus 2. But if it is, you do have to factor first before determining the LCD. So I know that my LCD can only be a minus 2. So that's why I'm going to multiply a minus 2. And we could do all of that, really, right? Well, let me not get ahead of myself. Let's just multiply all of that by a minus 2, all of the denominator by a minus 2. So you could potentially just do this, distribute all three terms if you wanted to. You could treat that a plus 4 here as a binomial and just FOIL it out here and then multiply it times 5 over a minus 2. So it doesn't matter. What I'll do is just multiply it by each term. But if you did it both ways, you'll see that it really turns out to be the same. So first, let's multiply a minus 2 times a. I'll put the a in the front here. Then we're going to have to multiply 4 times a minus 2. You see why I did that? I mean, it's kind of awkward having the a here rather than in the front. And then we're going to multiply a minus 2 times 5 over a minus 2, which is not a big deal because the a minus 2's will cancel, right? And then in the denominator, a times a minus 2. Again, multiplication is commutative, so order doesn't matter. 6 times a minus 2. And then a minus 2 times 15 over a minus 2. Alright, so the first thing we're going to do is multiply this a times a minus 2. So we're going to distribute here, so that's a squared minus 2a plus 4a minus 8 plus a minus 2 is canceled here, 5. And the denominator, we're going to distribute it again, so a squared minus 2a plus 6a minus 12 plus the denominators cancel. So we are left with that 15. Let's pull everything together, meaning let's add like terms. So we have a squared, we have a 2a plus 4a, which is 2a. Negative 8 plus 5 is negative 3. Denominator, a squared, negative 2a plus 6a is positive 4a, and negative 12 plus 15 is plus 3. Now, are we done with the problem? This is like your exit quiz. Are you done with this problem? No, not if it's factorable, right? If it's factorable, you have to factor to ensure that you can't simplify this even further. So what we're going to do is factor the numerator and denominator to see if we have anything in common. So we have easy case. So we have a times a. We got a 3 and a 1. So the 3 is going to have to be positive in order for that 2 to be positive here. So that's how I know I'm going to have a minus 1. And then in the denominator, again, we have 3 and 1, but both will be positive. So the a plus 3's would cancel, leaving us with the final answer of a minus 1 over a plus 1. So this concludes the lesson on simplifying complex fractions.